All right, so quadrilateral, that's anything with four sides. A parallelogram is going to be a quadrilateral where the opposite sides are parallel. So here's a little quick sketch of that. So here's what your basic parallelogram would look like. Okay? Now, here are your first properties of a parallelogram. At the end of the day, we're going to have four of them. Today I'm going to teach you four special properties of a parallelogram. So watch out for them. So here's the first one. If it's a parallelogram, then the opposite sides are congruent. So do what I do. Make yourself a little diagram like I just did. How would I show on this diagram that opposite sides are supposed to be congruent?
Use marks to show.
Right, you know how we mark things? Okay, mark those sides. Do that with me. Make your little picture. So this theorem is basically just saying here the opposite sides will be congruent. Like those sides will be congruent and these sides will be congruent. Okay? That's what theorem 5.18 says. Mr. Burton, do we need to memorize it by number? No, you do not. I don't care about 5.18. And then theorem 5.19. We change colors. Okay? If it's a quadrilateral, if the quadrilateral is a parallelogram, then opposite angles are congruent. So we just did opposite sides are congruent. Now we're going to go back to our diagram and mark opposite angles congruent. How do I mark angles to be congruent?
Like cuff.
He said cuff, okay? I see people making motions in the air like this, okay? We're going to make those little curvy marks, right? So everybody do that with me right now. If opposite angles are congruent, then, for example, this angle in that corner should equal this angle down here in this corner. And this acute angle should be congruent to the other acute angle, like that. Opposite angles congruent. All right, so that's what that theorem is saying. It's all about the angles. So I said there are four properties coming. That's two of them already. Opposite sides are congruent. Opposite angles are congruent for all parallelograms. So there are two more properties coming. Watch out for them. Now, how will this work in terms of problems? If I give you a quiz or something, what will the problems probably look like? Okay, so here's some examples. In fact, look, I'm going to do number 1 and 3, and then I'm going to pause, and you're going to do number 2 and 4. Okay, so looking at problem number 1, if I want to make some equations, because I want to find x and y, okay? Christian, can you tell me an equation that I could make out of problem number 1? Give me an equation, brother. Yes, because opposite sides are congruent, the 10 and the 2x should be equal. Agreed? So you can make an equation. 2x must equal that 10, and of course I'm going to just divide by 2 on both sides. So x is going to equal 5. Okay? Now, Josue, how am I going to find y, brother? Can you give me another equation? All right, dame otro ecuación.
Y plus 2 equals 16.
Perfect, okay? He said y plus 2 equals 16 because opposite sides are congruent. This side should equal that side. Subtract 2. That's going to give me y equals 14. Okay, pretty easy stuff, agreed? Okay, looking around, almost everybody had it right, so I'm going to do it very quickly. Opposite sides are equal, so 2a should equal 21. So 2a plus 1 should equal 21. Subtracting the 1, 2a should equal 20. Dividing by 2, a should equal 10. All right, looking around the room, that's what most people had. Okay, almost everybody. And then the same thing, once again, opposite sides are congruent. So 7 and 2b minus 3 should be equal. So everyone should have gone 2b minus 3 equals 7. You added 3 to both sides. That means 2b equals 10. Dividing by 2 gives you b equals 5. So a equals 10, b equals 5. Are we good? How we do? Wish we had a whole test of just this, don't you? Okay? All right. Everything we do is going to be almost that easy, but it'll be keeping it straight from all the little mini pieces is the hard part. All right. Now let's use the other property. You can probably just already know what to do without me telling you, but I'm going to tell you anyway. The other property that we talked about, we have opposite sides are congruent, okay? But we also have opposite angles are congruent. So now we did sides, now we're doing angles. Okay, so Tiger, give me an equation for number 3, brother.
Let's say 135
Mm-hmm.
equals 4 p plus 3.
Yes. 135 equals 4 times p plus 3. Okay? Simple. Obviously, what am I going to do next? What did you say? Yeah, you could totally divide by 4. That's a legitimate thing to do. Okay? I'm going to do it the other way you could do it, but dividing by 4 is a good instinct. That works. What else? Did anybody think of it a different way other than dividing by 4? Right. You could think of it as distributive property. Either way is fine. The only reason why I'm hesitating to divide by 4 is because I can see that it's not going to go in evenly. I'm seeing a decimal coming.
Yeah, 33.75.
Okay? And there may be no way to avoid that, but let's go ahead and do the distributive property and see if we still get a decimal anyway. So that's going to be 4p plus 12 equals 135. Subtracting 12 from both sides, that's going to give me 4p equals what? 123. Okay, so either way we're going to get that decimal, right? But at least we get to save until the end. Dividing by 4 on both sides gives us p equals what?
30.75.
30.75. Okay, so we got a decimal. So what are you going to do? So that's, no, let's leave it just like that. Any questions about number 3? All right, do number... Mo. Started recording. Looking around the class, most people had 13.
Yep.
Okay, because what did you do, Jill?
4m equals 52.
She said 4m equals 52. And then what happened?
And then I divided it by 4.
And she divided by 4, guys.
M
M equals
equals 13.
13. Muy fácil. Very easy. Okay, so let's move on. I promised you 4 properties. So far I taught you 2. Opposite sides are congruent. Opposite angles are congruent in a parallelogram. Let's see if it's time for the next property. If a quadrilateral is a parallelogram, then consecutive angles are supplementary. And what does supplementary mean? They add up to 180 degrees. Okay? Now, so there's a couple big words in there. Consecutive and supplementary. I need you to know what both of these words mean. Consecutive angles are supplementary. Well, I told you about supplementary. Supplementary means it adds to 180 degrees. Now, what does consecutive mean? Is there anyone, but usually Bryant and Jet are the first people to raise their hand. Is there anybody besides Bryant and Jet that can tell me something about consecutive? Jordan, let me give Jordan a chance first. If he's hesitant, but let me give him a chance. Okay, consecutive angles. Let me look back at my diagram. All right, let me put some letters on here so I can quiz you guys. Okay, say if this is angle A, B, C, and D. Okay? Haley, name two consecutive angles. In other words, tell me two angles that are right next to each other.
A and B.
She said A and B, right? You said B, not D, right?
And D.
You said D. Okay. A, though that's also correct. A and D are consecutive angles. Okay? They're two angles, like Jordan was saying, two angles in a row. In a row. So, angle A and angle D should be supplementary. Okay? Ashley, what does supplementary mean?
Same.
Not the same, because that would be congruent or equal. Any other guesses? Okay, Chase, what does supplementary mean?
They
Let me put like a supplement.
Come on, Chase.
Go ahead, Davon.
Isn't it next to?
That's consecutive. Okay? Jack,
Away from.
he blinked out.
I know the answer. What are we asking about?
Give me a number. Is there a number in your head somewhere?
No.
What's the question?
Assist. One.
Haven knows.
Oh, I see. Okay, so angles that are right next to each other add up to 180 degrees. That's what this theorem is saying. Let's see what the other theorem is saying. The diagonals bisect each other. Okay, well that's a bunch of things. You know what, I need new diagrams. I don't want to have to go up every time. Okay. Alright, so basically we had a big discussion about what it's consecutive and what supplementary means. So look, say if this angle down here is 80 degrees. Let me put my letters back. A, B, C, D. Angle A is 80 degrees. Everybody think silently in your mind what angle B is going to be. Don't say it out loud, but be ready for me to call on you. Think silently in your mind what angle B is going to be for 5 seconds. Okay, turn to the person next to you and tell them what angle B is going to be. Okay, Haven. What's going to be the measure of angle B? 100. Angle B is going to be 100 degrees because these are consecutive angles and they should be supplementary. Okay? And Ashley, what does supplementary mean?
They add up to 100.
They have to add up to 180. So if one of them's 80, the other one must be 100. Okay? Yes.
So it would say D also be.
All right, Jill asked a good question, which basically takes us back to what we were talking about before. You should be able to automatically tell me what angle C is also, shouldn't you? What's angle C, everybody? 80, because opposite angles are congruent. And what's angle D then, everybody? 100. Now I gave you nice, easy numbers. I'm going to erase these numbers and give you uglier numbers, and I'm going to still expect you to find all the answers. Are you ready? Okay. All right, so here's uglier numbers. Let's see. Let's say that this is 63.7. Angle A is 63.7. Take 60 seconds and figure out what all of the other three angles are. Go. All right. Miriam, can you tell me what you got for angle B? 116.3. Okay? If those are going to be supplementary, they have to add up to 180 degrees. So what you wind up doing is, Tyler, what did you do? How did you find that number?
180 minus 63.7.
Exactly. You wind up simply subtracting from 180. So everyone hopefully did 180 minus 63.7. That's how you do it. Okay? So Daniel, what's angle C going to be? Yeah, angle 3 will be 63.7 again. And Lisa, what's angle D going to be? 116.3. Okay? So, consecutive angles are supplementary. That was the third rule. Now we've got that down. Now we know opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary, adding up to 180. All right, only one more to go. So here we go. If you have a parallelogram, the diagonals bisect each other. Okay? So that's two words that you have to know. I'm hoping you know that second one because we've been just using it in with our triangles. Okay? So, Matt, do you remember what bisect means? What does it mean to bisect? This green word, bisect.
To cut in half.
Yes, Matt remembers. Bisect means to cut in half, down the middle. Okay? Now, what are diagonals? They're Zuni. This word diagonals, what are they? You said I don't know? Diagonals. Don't know? Word. What are diagonals? Do you know what those things are? Okay. Before I just ask a bunch of people, let me do a survey. This theorem says diagonals bisect each other. Raise your hand if you think you know what diagonals are. Okay, so we need to know what diagonals were. Diagonals go from one corner to the other like this. Okay, that's a diagonal. Let me make it red. That red line I just drew, that's a diagonal. Alright? So of course there are always going to be two diagonals, because here's another one. I should make this one purple, yeah? Why not? Color kings. Okay? Those two diagonals, those are the diagonals of the parallelogram. Now, Matt just reminded us that the word bisect means to cut in half. So this theorem is saying that if a quadrilateral is a parallelogram, the diagonals bisect each other. That means they cut each other in half. So if I put a dot right here, this dot is the midpoint of both diagonals. So these two pieces should equal each other, and these two pieces should equal each other. That's all that's saying. That's our fourth property that I wanted to teach you today. So let's look down and use these on these problems. So flip over. So we're on the back. All right, in fact, so you guys should be able to do this, shouldn't you? All right, I'm just going to pause for a while. All right, first of all, do not skip the giant problem at the top of the paper. Just because it doesn't have a number next to it, you still got to do it, okay? Now, listen to me very carefully. Jordan, listen to me very carefully. Jet, please stop talking. Listen to me very carefully. Please don't talk back. This problem it's easy, but it's one of the most commonly missed problems on the test. Because you guys have gotten trained, when you see two expressions, your instinct is just to set them equal to each other. Okay? You don't always stop and think about, does that make sense for them to be equal? You say, oh, I see an expression, I just set them equal to each other. But in this unit, very often that will be wrong. Sometimes it's right, but sometimes it's wrong. So don't just set stuff equal to each other without thinking. If you set 42 equal to 2x, you messed up on this problem. Okay? Do not set these equal to each other. Now think about it. This 42, is that an acute angle or an obtuse angle? This is an acute angle, less than 90 degrees. Look at this angle over here. Is this acute or obtuse? That's obtuse. I don't know what it is, but it's clearly bigger than 90 degrees. Does it make sense that these two angles should be equal to each other?
No.
No, I've got a small one and a big one. There's no way they're going to be equal. So that should help you understand not to set them equal to each other. Instead, I taught you 4 properties today. Opposite sides congruent. Opposite angles are congruent. Are these opposite angles, you guys? No. Opposite angles are like z and x. If this is 42, this will be 42. These will be equal. These angles are consecutive. Consecutive. What did we talk about? Jill, are you remembering? What did we say about consecutive angles? They're not congruent. They're not equal, but they are something. Do you remember?
They're alike.
Well, that would be sort of like congruent.
Well,
What's the relationship?
they would equal up to 180.
Ah, she got it. She got it. She said they have to equal up to 180. They have to add up to 180. That's what we do with consecutive angles like this, okay? So if we understand that these angles are, and the word for them is supplementary, they have to add up to 180, Haven says. So can you give me a new equation showing these adding up to 180?
Well, I did it differently, like
Ah.
people around me, but I just found like the other like corner, and then I did 2x equals 138, and I divided it by 2.
Okay, that would work, and there's nothing wrong with that. But just for fun, can you give me an equation showing these two adding up to 180?
2x plus 42 equals 180.
Okay, so one way to do it would be to do exactly this. 2x plus 42 should equal 180. That's showing them adding up to 180. Okay? And then you could solve this. And then I'm going to also repeat what Jill said, which is an equally good and valid way of doing the problem, the way Jill said it. But doing it this way, I could subtract 42. That would give me 2x equals 138. Thank you. And then I would just divide by 2 on both sides. X equals what? 69. Okay, so that's the answer that everybody should have gotten, 69. Okay? Now, listen carefully. I want you to understand and hear the way Jill did it, though, which was also good. So we're done with that, but here's another way to look at it. Jill looked at the consecutive angles Z and W, and she understood that those would be supplementary. So how did she find angle W then? How could you find angle W? You could just do 180 minus 42. And what did you get when you did that, Jill?
I got 138.
So she got 138 for angle W. And then she could just use an equation that therefore the 2x should equal the 138, because now they are opposite angles that she's dealing with. Okay? And of course that leaves you right there, so you're going to get the same answer. Either way, just as good. All right, moving on. Look at number 5. We're supposed to find the length of PR. Notice, I'm not just asking you for a variable. I'm not just asking you for x or n or m. I'm asking you for the length of PR. So once I find the variable, I'm going to have to plug it back in to find this answer. Anyway, PR. PR is the whole thing. Do you understand this? PR is from P to R. That's from here to here. PR is the whole length. So look, let's just find all the variables, and then we'll worry about what they are asking us later. I need some equations. Okay? Let me talk to people in the back. People like Aaliyah. Aaliyah, can you just give me an equation? Look at this picture. Just give me an equation. Something equals something. Okay, so here are two things that should equal each other. I need a better color. For example, 3m should equal 15. Okay, because they're two parts of the same diagonal. So they should equal each other. So let's do that. So 3m equals 15. So if I divide by 3 on both sides, that gives me m equals 5. Okay? Notice that is not any of the answers. That's just a variable. So there's more we'll have to do later. We'll come back to that. Okay, somebody else in the back, like Flavon. Give me another equation, brother.
Well, 2n equals 12 minus n.
Absolutely. 2n should equal 12 minus n. Because these are two parts of the same diagonal. So those two should equal each other. Okay, am I losing anybody? Is this making sense, Haley? Okay. So let's solve this. So on this one, I would add n on both sides. Plus n plus n. That's going to give me 3n equals 12. Divide by 3. So n equals 4. So I've got n and I have m. What do I not have yet? I haven't found x yet. New color. Let's try orange. Okay? Now the x's are involved in these angles. All right, we just talked about this, so I'm hoping everybody's up on it. Lisa. Okay, we've got these angles. We've got this angle, and then we've got this angle over here. Lisa, will these angles be equal to each other? The angle S and angle R, are they equal to each other? No. Okay, Andrew. So, am I going to just set 5 times x plus 1 equal to 2x? No. I'm betting at first a bunch of people just set those equal to each other. All right? That's not going to work because I got one's big and one's small. Andrew, what is the relationship between these two angles? If they're not equal, what are they? Just describe it. They're next to each other. So numerically, what will I do? How do they compare to each other? And what should they add to be? I need details. Let's look back at the giant problem we did at the top. Okay? What do these angles have to add up to be? 180. Okay, those consecutive angles are supplementary. It's another vocabulary word I want you to own. Those angles have to add up to 180. Okay? So look back at this problem, you guys. Overshot. These two angles have to add up to 180. So, give me an equation, Andrew. Give me an equation showing this and this adding up to 180. Go. Read this. Right, 5 times x plus 1. Oh no, now you're just setting them equal to each other. Pause. Yeah, it's true. I'll change colors in a second. Okay, look, Andrew, here's the deal. You were telling me, what is the relationship between these two angles? Are they equal to each other? No. So what are we going to do with them? Add them to 180, okay? That means this one plus this one should equal 180. So I'm just wanting you to read this one, and then say plus, and then read this one, and then set it equal to 180. So what comes next?
I don't see where
I don't know. Yeah, I don't know your point.
Wait, what are you pointing?
These are supposed to add up to 180. So I want you to say this one plus this one equals 180. Okay. Right. 5 times x plus 1 plus 2x should equal 180. That's the equation that everybody should have. Okay? All right. I'm betting a lot of people did not have that at first. And then solving it is the easy part, but Does everybody understand where the equation came from? Then you would do the distributive property and all this. So that's going to be like 5x plus 5 plus 2x is equal to 180. Like terms, 7x plus 5 is equal to 180. Subtracting 5 from both sides. So that gives me 7x is equal to 175. Okay, what's 175 divided by 7? 25? Wait, is that right?
Yeah.
Okay. What?
We just started off with 7 plus 5.
Say again?
What if we just started with 7 plus 5?
That's fine.
And then what do we do now?
Okay, now that we have all the variables, we can plug them back in to find anything we want to find. So for example, looking at number 5, we want PR. PR is the entire distance all the way across. So let's see. On the left side, we have 3m. 3m is 3 times 5, which is what?
15.
Which is 15. So this side is 15, which means the other side, well, yeah, you know what? I didn't even have to do that. So they were both going to be 15 anyway. So 15 and 15, so that's going to be 30. If I want ST is 12 minus n. So that's going to be 12 minus 4, because n is 4, see? So that's going to be 8. Okay, if I want angle SRQ, SRQ is this acute angle over here. Okay, this is angle SRQ. That angle is supposed to be 2x. So 2x, so that's 2 times 25. So that's 50.
It's getting a little crowded.
I know. SRQ was 50 because that's 2x, so that was 2 times 25. That means the other angle,
How'd you get that? Can you redo that one?
you see the 2x?
Yeah.
That's the angle that we're looking for.
Okay.
But we know-
We know what x is, so 2, 25,
That's it, okay? That means the other angle, PQR, right, it's got to be, no, supplementary. These two angles are consecutive. They're not across from each other.
PQR.
All right, so if this one is 50, the other one should be 130 because they've got to be supplementary. They have to add up to 180.
Where's the other end? At the top?
PQR is like this angle right here is angle PQR. Okay, so that angle must be 130 because they have to be supplementary. They have to add up to 180.
All right, it's time to do number 9, the last question of the lesson. Let's go. Let's see. I feel like we're gonna need a parallelogram, so kablow. WXYZ, let's do that. Alright, W is bigger, so I'll let W be one of my obtuse angles. So W, X, Y, Z. Okay. Angle W is 50 degrees more than angle X. Okay, so I'll call angle X, X. I'm going to switch to red. Say if angle X is X. Angle W should be 50 degrees more. So that would be X plus 50. Okay. Now that means these two angles are supplementary. See how they're right next to each other? One's big, one's small. They're not equal. They are supplementary. That means if I add them up, they should equal 180. So x plus 50 plus x should equal 180. Combining like terms, let's see, so we have x plus x, that's 2x, and then we still got the 50, so that's 2x plus 50 equals 180. Okay, all I did was combine like terms. Then I would subtract 50 from both sides. Okay, so that's going to give me 2x equals 130. Then I'm going to divide both sides by 2. Alright, divide by 2, divide by 2. That's going to give me x equals, see, 65. Okay, x equals 65. Alright, so we're supposed to label each angle with its measure. I'm going to go ahead and draw a whole new parallelogram because I did all this work. You know what, I probably could have just copied it. Okay, so we're supposed to label all these, so I've just taken this image and copied it over here. So we found x. X is 65. Remember, x was angle x right here, so that means angle x is 65. Okay, that means angle z is also 65 because those are opposite angles. So this will be 65. Okay, what about angle W and angle Y? Well, really I have a choice. I could either use this formula and do x plus 50, or I could subtract from 180. I could do 180 minus 65. I'm just going to do the 180 thing, why not? So if I do 180 minus 65, that should give me the other angle because these are supplementary. Okay, so what's that going to be? That's going to be 115. So that means I'm going to take that. That means this is going to be 115. And this is going to be 115. And that is how you do number 9.